So I actually have no idea why people tend to confuse the concept of pointers in C or any C++ like programming language. Yes, I do understand that pointers is a bit different type of thing. It allows us to deal with the memory level of the computer, but it makes absolutely no sense in saying that yeah, it deals with hardware level, it deals with the memory level, so it might be complicated. Yes, people do exist who will tell you that concept of pointer is a very difficult one and it's not easy to understand, but no, it's very simple to understand if you have the mindset of keeping it straightforward. So hello everyone, welcome to this new video of this C++ series. In this series we are learning C++ from very start to the end of this object-oriented programming parts, and in this video itself we are going to learn about the concept of pointers. So what are actually pointers in C++ or C? Both the things are same. Now before directly coming to the pointers, let us understand how the memory addressing or how the RAM of the computer is storing stuffs for us. Now if you go back to the second video or the first video of this series, I have explained to you about the concept of variables and data type in that video. In that video, we found out that using the size of operator, we can find out the size which is allocated by the variable in our RAM. So likewise, we found out that integer was taking 4 byte, character takes 1 byte, float takes 4 byte again, double takes 8 byte. Now, where are these actually things getting stored? Where are 8 bytes getting allocated for my variable? Because variables are containers, they do have some capacity. But inside the architecture of our computer, where is actually the variable getting stored? The variables, everything that you declare gets actually allocated some space in the random access memory or the main memory or the RAM stick, which you call in modern days. Every variable that you declare in your code, it's stored in the RAM of the computer. So if you go and see the RAM stick, it will look like this vertically long RAM stick. It will have various chips in it which are arranged serially parallel to each other, right? So if you go and understand the internal of the RAM, you will see that the RAM consists of various blocks. You can assume that the RAM consists of various blocks. So as you can see, this is the internal working of the RAM, internal structure of the RAM, and everything that you see over here, there are the various blocks. This RAM is consisting of various blocks with some sort of numbers. Okay. Now these numbers are nothing, just the address of this particular block. Means the first block is of 100 address, second block is a 101 address, 102, 103, like this. Every block is of 1 byte. Now what is 1 byte? 8 bits make 1 byte. So every block present in the RAM is of 1 byte. So if I tell you that you are declaring a character, say A, which is storing the value H, and that character takes 1 byte, that means that character will obviously take 1 block, or this block, 100 block in the memory. So what does it mean when you write, say, int a equal to 5? So when you write int a equal to 5, inside this memory, 4 blocks of space are getting acquired by this int a equal to 5. Why 4 blocks? Because every block takes 1 byte, and since we already know in 64-bit architecture the integer takes 4 bytes of space, so consecutively 4 consecutive blocks will be reserved by this int a equal to 5. So if I just want to override the color of this block, so will this give me the permission? Yeah. So yeah. And inside this, if I highlight this, so it will be A. So how many blocks will my A take? My A will take 4 blocks of space inside the RAM. So why 4 blocks? Because every block is of 1 byte, and since my A is of integer type, it will take 4 blocks, that is 4 byte. And here in this A, my 5 is stored not directly but in form of the binary number, because the computer actually understands zeros and one in form of binary. We already know that, right? So my A is taking 4 bytes, that means 4 block of space inside the RAM. So this was how the memory organization or the variables are stored in the computer's memory. Now again, for instance, if you say char C equals to H. Okay. Now what does this mean? When you write char C equal to H, just a minute. Yeah, char C equal to H. This means that the C is the name of a container which will have 1 byte of space allocated for it inside the memory. So again, my 104 block is free till now. So for that, So for that, in this space, C will be placed. And how many blocks C will take? C will take only 1 block, because we know that char takes 1 byte of space. And inside this, inside this C, my H will be stored actually. Okay, so let's not make this dirty. C equals to H, and this H will also be stored in form of ASCII characters, which is some form of integer value assigned to some characters of English alphabet, okay, which allows it to be additionally represented in form of binary, but that's a separate discussion. So in this way, the variables are actually being stored inside the memory. Now this was a part of this video. If you have not understood, I would like to request you to kindly do rewatch the part which I have covered till now. Now we will understand the concept of pointers. Okay, so let's move it a bit down and make it a bit shorter. Will it allow me? Okay, so it doesn't allow me. So might be if I make this text small, it will allow me. Okay, that will be fine. Now we have seen that integer takes 4 bytes in the memory, and every byte or every block of memory will have a particular address. See, 100, 101, 102, 103. Okay. Now what are pointers? Pointer is another type of variable which is used to store the address of another variable. Now what is this? What is the address of A over here? So the address of A is actually 100. That is the starting address we generally take. We generally take the starting block's address to be A's address, because A is getting allocated from 100. So we say that the address of A is 100. So if you group these 4 things, okay, just a minute, let's copy this and A. So our A is being stored in these 4 blocks, right? So we can do clubbing like this, and this our A is being stored over here. This is our A, and it's for storing the value of 5. Okay, so my A takes 4 bytes of space, and you can see the thing is allocated over here. Very good, as clear as that. And what is the address of A? So I have mentioned that we have the address as the starting address of the memory location. So the address is 100, right? Because the starting address from where the A gets started to be stored in the memory is 100, right? As clear as that. So my A is getting stored in 4 bytes in the memory, and the byte allocation starts from 100. So the address of A is 100. So what is the role of pointer over here? The role of the pointer is actually to store this 100 value. Means if I want to store the address of A, that is 100, I will take the help of another pointer or another variable which is called the pointer, which will store 100. So pointer is actually a variable which is used to store the address of another variable. So what you can say that if this is my A, okay, and this has an address of 100, okay, this has an address of 100, When I am writing a pointer is written like this: integer star ptr, say the pointer name, and ampersand a. So what will happen after this? Integer means the type of the variable whose address you are storing. So you have to mention the data type of that pointer as the same as that. So what is actually the ptr doing? So ptr is also a variable, obviously. So ptr will also take some space in that memory. So ptr, just a minute. So this is, say my a was holding a value of a4, and this was my a. So this is my a, and it was storing the value of 4 at the memory location 100. Okay, let's remove this. Okay, I will come to that once again. So what is my ptr now? My ptr is actually a pointer with which I want to store the 100, that is the address of a. So ptr is also a variable, so it will also take some location in the memory. Suppose that location is 200. So ptr takes 200 location of the memory. Now what will be the value in this ptr? The value in this ptr will be 100. So this ptr will be pointing to this 100. Just a minute. ptr will be pointing to this 100, and the value which will be stored here is 100, because it is pointing to a. A has an address of 100, and that 100 value or address will be stored by the pointer, which is 100. Okay, now how do we declare pointer? So for declaration of pointer, the first thing which you have to note is you have to write the data type of the pointer, followed by the pointer name, and here you have to put an asterisk, which is notifying that yes, this is a pointer. And if you want to assign some value, then you can write ampersand, then the name of the variable whose address you want to store, variable name. Okay, so like this, if you want to declare a pointer, suppose this pointer ptr, which will store the address of this a. So for doing that, we can write it like this. So my pointer will be of integer data type, means integer pointer. Why? Because it is storing the address of an integer value, which is a, which is equal to 4. So I will write int star, which is notifying that yes, this is a pointer type variable, and my pointer name. So what is my pointer name? My pointer name is ptr. Say ptr pointer. Okay, so you have to keep the names easy for us to remember, right? So int star ptr pointer. So int star ptr pointer is a pointer variable, right? So if you want to assign some address to this, or if you wanted to store some address, you have to assign it with the help of ampersand and then the variable name whose address you want to store. So here I was storing, so this will be ptr pointer. So here I was storing the address of a in this ptr pointer. So we have assigned that ampersand address of a will be stored in the ptr pointer, which is of pointer data type. Now the magic lies in this place. With this ptr pointer, now since I know the address of a, I can also access what is stored inside a, that is the value of 4. Now with this ptr pointer, if I do cout star of ptr pointer, I will get my output as 4. Okay, so this is not the way of doing it. I'm writing this. Now what does this mean? C++. Okay. So what is happening over here is we have declared a pointer which is storing the address of variable a, and with the help of that pointer we are finding out what is the value stored in a, that is 4. So this is called the dereferencing of the pointer. So for dereferencing the pointer or finding out what is the value stored in the address which is pointed by the pointer, yes, to find out the value present at the address pointed out by the pointer, we are using the asterisk, which is called the dereferencing of pointer, and we are finding out the value present over there. So let's Now go to our code editor and let's execute the things, and we will understand it in a much better way. So before going to the code editor, it's important that you keep in mind that you are not going to get 100, 200 as addresses, because inside the computer's main memory, the addresses are stored in hexadecimal. So you will see a different kind of address present over there. So let's go to our code editor. This is the code which we have done previously. I will not erase this. I will just keep it as it is. I will not do anything. Just comment it out for the bit, for the time being, and I will explain you something here. Okay, so suppose I have a variable, say a, and the value present over there was 100. Okay, now I want to create a pointer which will store the address of a, and with that pointer I am going to print 100. Okay, so my pointer will be of the same data type as the variable as I am storing the address. So it will be int star ptr. Ptr is my pointer name, and inside it I am going to store the address of a, so using ampersand a. As clear as that. So int star ptr equal to ampersand a. With this we are assigning the address of a in ptr. So once that is done, my ptr has now the address of a, and using this we can access what is stored in a. But before accessing what is stored in a, let us see what is the address of a actually. So if you do write like this, address of a is, okay, and here you can write ptr. Okay, so if you run this, you're going to see some sort of weird numbers. So the address of a is 0x61ff08. So this is a hexadecimal representation of the address, which is coming like this. So this is the place where a is stored. Now I want to find out what is the value stored inside this a. So for doing it, I want to dereference the pointer. So see, you can do cout a also, but there comes situation where you have to explicitly use the pointer to find out what's stored over there. Yes, there are situations like that. So we will just copy this line and we will say the value present inside of a is, we will just write start of ptr. So once we are writing start of ptr, we are actually dereferencing the address which is present inside the pointer. So if you do like this, you will get that. So let's write an endl to improve the readability of the code. Okay, so when you run this, you will see the address of a is this, the value present inside a is 100. Yeah, that was the thing which we were achieving here, right? We were storing 100 in a and you were printing the same bit like this. So this was about the concept of pointers, right? So now we will understand what we are doing in the concept of addressing. So one last thing that I would like to add in this tutorial, that is, I would like to explain you what we have done in this swap to numbers in call by reference. While teaching also call by reference, I have explained you that these are actually pointers, but I have not explained how this swapping is actually happening. So after this pointer concept, I believe that call by reference will be much more easier to understand. So let's see what is actually happening in this code. So let us comment this part for the time being, and we will just run this code again to understand what was happening over here in this space. So let's uncomment this, and so let's run this code and let's understand what's happening here in this code. So if you see, it's asking us for entering two values. So let us enter two values, say 10 and 20. So you can see the swapping is happening successfully. Now what is actually happening here, I'm going to explain you now. So once you are calling this swap to numbers x and y, you are actually sending address of x and address of y. Now since you are sending the address of x and address of y, you need some sort of pointers for storing these addresses. Now these pointers are int star x and int star y. So since they are pointers, they are storing the address of the x and y variables which you are passing as a parameter to this. Now once I have the address, by dereferencing the address, we can find out what is the value stored in this address, right? So for finding out what is the value stored in x, we are writing int x in temp equal to star of x. So temp becomes a variable which is storing the value present at the address pointed by out this x. So that is being stored at the temp. Now once this is done, we have star of x equal to star of y. So what's happening is that the value which is stored at the address pointed out by y is stored inside the address x is pointing to. So x is pointing to address, y is pointing to address. So the value present at the address pointed by y is stored in the address which is pointed out by the x. Okay, so after this star of y equal to temp, so in the address pointed out by y, we are storing the value present at temp. So that's how our swapping algorithm is working, and it is swapping the two numbers by taking them as reference. So I believe after the concept of pointer, understanding what was being done in the call by reference video is quite easier for you to understand now. So that was about pointer. I have mentioned that it was very easy concept for understanding pointer if you have the intention of keeping it as simple. So that's all in this video. I will see you in the next video where we will understand the concept of object-oriented programming in C++. Now wait, in many courses or tutorials you will find out that after the concept of pointer they are directly jumping into the concept of arrays. But I would like to keep the concept of arrays aside for the time being, and I would like to focus more on the object-oriented perspective of the C++. Why the C++ is so much special over the C programming language? See, up to now what we have seen was everything was there in the C language as well. Now what is special in C++ is the object-oriented perspectives of C++, which you can say revolutionizes the software development methodologies. So we will jump to the object-oriented perspective of the C++ from this point of time, and the arrays concept we will understand in the data structure series, because array is actually a storage location, right? So the array concept we will understand in the data structure series, which will come shortly after this series. So thanks for watching. See you in the next video with the object-oriented programming concepts of C++. The video is going to be a bit theoretical, but I will try my best to keep it informative and engaging to you. Thanks for watching. I will see you in the next video.